Hello, good day, everyone. How are you? Wish all the best. Okay, at the moment, we are going to talk about assembling the source code. What I mean is assembler source code. In this discussion, we take a very simple example to calculate data 5 equals to data 1 times data 3 plus data 6. This instruction in assembler coding will be coded like this, not one instruction like this, because assembler is very primitive. It just directly representing the machine instruction. So the source code will be first is getting the base address by instruction of branch and shift register 12, and then this is using is not instruction for the machine. Using is just assembler instruction to assign register 12 as a base register. Next is load, following by multiply, following by add, followed by store, and then the last is return to the color. Okay, the first thing assembler do is calculating the displacement of each instruction to find out the address of each instruction and convert all implicit address to the explicit address, mean decode the addressing. Okay, the first thing, assembler will read the using instruction. Here, it assigns the register 12 as a base register. Then, since this instruction is assignment to the base, then next instruction must be located in the displacement of 0. The instruction should load the content of data 1 means the content of memory which is labeled as data 1 into the general purpose register 1. This instruction got length of 4. When I said 4, when I said the number means byte, so 4 means 4 byte. Next is MH instruction, multiply half-word, means the content of memory pointed by label data 3 is multiplied to the content of the register 1 and the result is stored into the register 1. This instruction also got length of 4. Next, the displacement is H because 4 plus 4. Instruction A means add. The content of memory located by a label data 6 is added to the content of register 1 and the result will be stored in the register 1. This instruction also got length of 4. Next must be 12. As it is in a hexadecimal, then we call it C. ST, store. Store the content of register 1 into the memory labeled as data 5. This one. Next, the displacement is 10 hexadecimal because the length of store ST instruction is 4. Hexadecimal C plus 4 or 10. In this displacement, the instruction is branch 14, unconditional go to, unconditional branch into the memory, which is its address is contained in the register 14. Next, memory labeled data 1. The displacement must be 1 to hexadecimal, 12 hexadecimal, because the length of unconditional branch instruction is 2. 10 hexadecimal plus 2 or 12 hexadecimal. The data 1 is a forward, here coded as minus 25. Forward is a 4 byte. Next, data 2 is a forward which contains of binary 5000. Next is half word, 2 byte length, contain of binary 2. Next, data 4. 16 hexadecimal displacement plus 2 become a 1C hexadecimal. Data 4 is a hexadecimal notation, here coded as a 4-digit. Actually, only 2 bytes because one hexadecimal byte is coded into 2 digits. So the displacement is added by 2. So next will be 1E hexadecimal, data 5. It is just a storage full word, means the length is 4. The last displacement 1E plus 4 got 22 hexadecimal, 22 hexadecimal. The content binary 100. Next, instruction before the using. The displacement must be minus. This instruction is to get the address in where this module is loaded, and the address will be stored in the register 12, which is in the next instruction. This register is assigned as the base register. Now, converting to explicit address means decoding assembly into the machine instruction. Data 1. Data 1 actually is just a label. This explicit address is displacement plus the content of base register. 12 here is base register. 12 here is displacement. Next, data 3. Displacement of data 3 is 1A. Then the data 3 label is converted to explicit address as a displacement 1A using base register 12. Next, data 6. With a similar way, become like this. 22 hexadecimal displacement for base register of 12. Next, also the same. The displacement is 1E, so it will be decoded like this. Next, branch 14. Branch is actually not a real machine instruction. It's just a symbolic mnemonic, and it is converted into the real machine instruction BCR, as it is unconditional. So the mask will be F, all 4 bits on. This means branch unconditionally into the address in the register 14. Next, back to the top, branch and save register. This mnemonic then translated into the real machine instruction in hexadecimal notation, OD. And the register number 12 also converted into C. Register will be coded in 4 bits, and the second operand also register, even though in this case is not used. Using is an assembler instruction, so this just ignore. After everything become explicit, then using instruction is no longer used. Load. The mnemonic L is converted to machine instruction 58, and the operand is converted like this. Register 1 and register base register become C. Next, MH converted into 4C machine instruction following the operand. A also with a similar way, store also like that. BCR 07. Once everything is in hexadecimal, DC is just assembler instruction, also ignore. Then everything we arrange become hexadecimal notation, all. No more symbolic, no more instruction, just hexadecimal. The CSEC name is depend on how you produce the result of assembling. It is kept in the object, and next is aligning according to the memory word like this. Regardless length of each instruction. Alignment complete, and the objects already in a memory format as a machine code. Then depend on what type of the product you want to produce. You can select the deck and load module. If you select the deck, entry name and IT 01 and other attribute is not saved. If you produce loop module, all attributes will be saved in the module header. Now everything complete. Thank you for watching. Good day.